Have astronomers finally explained space's Bermuda Triangle, the South Atlantic Anomaly? A curious pattern in the sky has made astrologers scratch their heads for decades. Is it real? Do astronomers know what this is? Are they working on the way to explain it? A team of scientists is attempting to crack one of the biggest mysteries of all time. Scientists have an explanation for a mysterious phenomenon called the South Atlantic Anomaly. Many of us have probably heard of various times about the Bermuda Triangle. It's an area that is said to have several unexplained disappearances and crashes in it. But there's another mystery out there. This time, instead of strange stories in the Atlantic, it's a strange one in the universe. The South Atlantic Anomaly is a region of space that has baffled scientists for years. But no more. Scientists have finally explained it. And thanks to some new research, this mysterious phenomenon seems less mysterious than ever before. Want to know more? Then watch this video till the end. Most of us remember hearing of the unexplained Bermuda Triangle, but scientists have been stumped for a long time by something similar causing trouble in space. Since the 1600s, many mysterious missing people and ships have been faulted on the Bermuda Triangle. Numerous aircraft and ships that attempted to pass through the area west of the North Atlantic Sea mysteriously disappeared. This has made conspiracy theorists interested in the area. The region is located above the South Atlantic and goes from Chile to Zimbabwe. It is also called the South Atlantic Anomaly. Even though space probes don't just vanish out of nothing, this big region has already been accused of certain strange things that happen. Not just the latest of which is messing up machinery and bringing astronauts at serious risk. In contrast to the Bermuda Triangle, we may still be able to figure out why its space twin is up to no good, and it has nothing to do with aliens. It is located where the inner Van Allen radiation belt is nearest to the planet's surface. The Earth has two Van Allen belts. These are two bands of charged particles that encircle our Earth and are held in position by Earth's magnetic field. The inside is mostly made up of high-energy protons, and the outside is mainly made up of electrons. Since the belts catch the particles coming from the solar surface, they keep dangerous radiation from affecting the surface of the Earth. Here, Earth's magnetic field is minimal. This indicates that the cosmic particles from the Sun are not restricted in the same way they are in other places above the Earth. Because of this, the Sun's rays can get near 200 kilometers to the planet's surface. What does the South Atlantic Anomaly exactly do with spaceships and astronauts? The Van Allen belts are between 1,000 and 60,000 kilometers over the planet's surface. But because the radiation hub is at a lower height, it is in the circle of some spacecraft. These spacecraft are struck by protons with more than 10 million electron volts of energy. This impacts the electrical components on the spaceship, making it hard for them to work and forcing aerospace companies and other spacecraft technicians to turn them off. Do you know the Hubble telescope does exactly the same thing? It goes from the SAA 10 times daily, so it already spends about 15% of the overall time here. Over these times, Hubble can't collect astronomical info, which may not be preferred but essential. Many individuals are unaware that over South America and the Southern Atlantic Ocean, the weakest point in the planet's magnetic field is about the size of the United States. Wait, what? We're fully protected from every consequence here on the planet's surface, but our spacecrafts aren't quite as fortunate. Because once they fly through this magnetic anomaly, they get hit with more radiation. If you didn't take safety measures by closing the spaceship, the system might screw up. Astronauts have seen this happen with computer systems on board spacecraft that fly close to the SAA. The SAA might also prompt very expensive destructions, like when it brought the Japanese satellite Hitomi falling to Earth. The Japan Aerospace Exploration Agency, JAXA, asked Hitomi, also known as Astro H, to research powerful cosmos operations. A little more than a month after it was released in February 2016, its technicians failed to keep up with it. It broke up into multiple bits. Afterward, findings demonstrated that perhaps the issue was caused by the spacecraft's inertial coordination unit, which is kind of motion detector, disclosing that now the spacecraft was rotating at 21.7 degrees per hour when it was completely fixed. So, when the attitudinal management system tried to stop the rotation, a series of things happened that resulted in it bursting. If the technicians were able to recognize the mistake right away, they might have fixed it. But it occurred while the spacecraft was within the SAA, so there was no way to talk to it. There was also a chance that the vast radiation levels hurt the computers. The sad story cost JAXA approximately $273 million and took about 3 years to study. Even astronauts can be directly affected by the SAA in Bermuda. A few more astronauts on NASA's ISS have said they saw strange white lights flashing. To decrease ray's effect, the most used section of the ISS, like the sleeping area, have a robust protective coating. Astronauts carry dosimeters, which are instruments that monitor their dose of radiation and issue an alert if they attain dangerously high levels. Now, let's discuss what actually causes SAA. So, why is there a lesser magnetic force just above South Atlantic? The reason is that the planet is not a perfect circle. The central part of the Earth has a subtle lump, and the dipolar field is almost 500 kilometers far from the center. The multi-material stream in the planet's external core creates electrical impulses that power a dynamo that keeps the magnetic field going. So, when Earth spins on its axis, liquefied, charged materials moves around chaotically. This creates the magnetic field and provides the Earth with its south and north poles on the ground. At present, the magnetism in the SAA region is getting weaker, which indicates that the region is getting bigger. In 2018, scientists in Africa discovered an unusual piece of geology proof that assisted them in figuring out what the planet's magnetic field felt like decades ago. Bantu farm owners who resided in the Limpopo River Valley in Africa 1,000 years ago would burn down their ritual areas during dry spells to start over and wait for the rain to come. When the soil was burned, it released magnetic minerals that aligned with Earth's magnetic field till it cooled. This gave Tarduno and his co-workers a wonderful photo of the magnetism at a particular moment. "We found something unusual about the core mantle boundary under Africa," Tarduno said, "which may be changing the magnetic field around the world." Researchers have also wondered whether this means the magnetic field will switch. Rays in the SAA have also been studied more to determine how dangerous they might be at various levels. This is crucial as the SAA grows. It will not just lead to more issues with computer systems and other technological devices on the planet, but it may also make cancer more common. Riccardo Campana at the National Institute of Astrophysics in Bologna, Italy, discovered that the lower strands of the SAA have less radiation than the surface layer. Even if the magnetic field changes direction, Bermuda still has a magnetic field, even though it is much lower and much more complicated than it is today. Now anyway, space travel is the most important thing, especially since the number of satellites and space probes that take passengers will grow. It is very important to understand how the SAA works, as it is expanding at a rate of 19.3 kilometers annually and will shortly wrap a much larger area than it currently does. And here's the end of today's video. Go over to our comment section to tell us what you think of this video. Also, comment your ideas on what you would like to see in the next videos. Thanks for watching. Bye-bye.